Hello everyone and welcome to another CNCF Oran Community here, where we try each time to talk about some specific topic in the cloud and CNCF world. And today's subject is more about observability and monitoring. And more specifically, it's cloud native observability with LGTM stack. It includes Loki, Grafana, Tempo, and Mimir. Today we are joined with Walid, a fellow cloud enthusiast, and Abdelkrim, a solution engineering manager at Grafana. Abdelkrim, if you'd like to introduce yourself.
Yeah, sure. Hi, everyone. Assalamu alaikum. Thank you very much for having me today. So I'm Abdelkrim. I'm based in France. I work as a solution engineering manager here at Grafana Labs, a software vendor that create the well-known Grafana tool as well as different monitoring platform for Kubernetes and cloud native world. Yeah, I have been working in this space since several years, and before that, I went through different jobs like developer, researcher, and also consultant. And yeah, it's a pleasure to be with you today and talk about the LGTM stack.
So I suggest you to wait until 5 minutes so we can start our session.
Okay.
Okay. So. So Abdelkrim, it's time. So the stage is yours. If you need anything, so just ping us.
Okay, perfect. Thank you very much. So again, hi everyone. I don't know if other people join us since we kicked off. So today we'll be talking mainly about observability in cloud native world, and specifically for a set of open source tool called Loki, Grafana, Tempo, and Mimir, which makes the name of LGTM stack. It's also reference to looks good to me in English. Yeah, so before kicking off the project, the presentation and go into details, I think, or at least I hope, majority of you knows the Grafana UI. So it's a really famous open source tool used by SREs, site reliability engineers, and also developers to monitor their systems. So Grafana is really well known for like a large number of connectors. You can use it to show data from different data sources like Elasticsearch, Zabbix or Prometheus and things like this. And it helps people build these dashboards to monitor their systems. It can be also used in some BI tool project or Internet of Things project as well in the community. So this is like the most famous product that we built at Grafana Labs. But there is also many other things that we participate in that a lot of people don't know. So we have this LGTM stack, which is 100% open source solutions to monitor your application and your Kubernetes clusters. And also I participate in projects like Prometheus or OpenTelemetry if you have been looking to do tracing and monitoring in monitoring application microservices as well. And also we have announced some like other open source project like FLAR, which is for profiling, or Faro for front-end monitoring. So the idea here is we are contributing in different projects to make it much easier to monitor. So all this product can be built in one big platform that gives the SREs all the function and features that they need to be able to understand how their application, cloud native application, are behaving, how much resource they are consuming, and things like this. So at the top level, you have Grafana UI that help you connect to many data sources. As I said before, it can be like open source data sources, or even enterprise like Splunk or Datadog or something like this. And in the middle, you have the metrics and logs and tracing component. It's mainly the database that collect telemetry data from your infrastructure, your network, store them, and you will be able to do alerting or query and things like this. And then we add a few other components around load testing or incident management. For instance, when there is an incident, who is the person that's on call? How can I contact him or her? Is it with Slack or with SMS or phone call or email or something like this? And if this person is not answering, who will be the next person to reach out? So all of these make like a full platform, but today we will focus mainly on these three pillars, which are metrics, logs, and traces. Before talking about the technology itself, let's review the three pillars of observability: metrics, logs, and traces, and why they are all important. So traditionally, it has been pretty much easy to monitor infrastructure and application, especially when you have a monolithic application. So you have your code running somewhere, is it in Java or .NET or any language that you write, and you can have like a database, and it's enough to monitor these 2 or 3 VMs and the database and the application. You can have high level of information. You can build alert on that, and that's it. So you can collect application from, I would say, logs from your application, store them in Elasticsearch, for instance, and that's usually enough to have a good visibility. But with the emergence of cloud native application, a lot of companies and people started breaking down their application into different microservices. It can be large number or small number, but nevertheless, we try to split the work of the application into different services and have these services communicate between them. So it has the benefit of making it easier for teams to maintain different part of the code. So for instance, the API service can be written in a language and the processing service written in another language. And if you want to add, let's say, new feature in the processing service, you don't need to touch the others. So the risk of having bugs in other part of the application can be reduced. It's just enough to have like a contract between the two services, the API, protect them, and that will be enough. The other benefit is that every service can be scaled independently from the others. So if you have a lot of users going to your website, but not much are, for instance, processing the data, you can just increase the API service and increase the level of replication, going from 2 to 4 services, for instance, and you don't touch the processing service. And this way you can control the cost while you have this scalability. So all of these are good things, right? However, it's making things also more complex because you need to manage replication, you need to manage intercommunication between these services. The more replica you have from each service, you need to be able to monitor. And what happens if your user is complaining about the service or the website being slow? Where is the problem? Is it at the API service? Is it at the processing service? Is it at the database? Is it a combination of both? So it becomes really hard to understand what's happening. So let's say there is a user that connect to your website. The transaction will go over load balancer. It will pick one of the services based on the loads or availability or something like this. Can be just random. So if you start measuring when the transaction reach the API service, you can get time to this particular service, right? And then it will be moved to the next phase, the processing service. So you, for instance, you extract the data from the HTTP request, you do some processing, and then you want to store it in the database. So same thing, you measure here the time it took for every service, and then store in database and do the same thing. And then whenever you have the result of that, it goes back into the users and you show the result. Let's say you search for, I don't know, cars, and you get the result of that in the web page. So like in the past, if we were only interested by one metrics, which is how long it takes to show the web page, here it become many different metrics, like how much time we take to go over the load balancer, the API service, processing service, database, and so on. And if you have a log saying that your application has an error, in which service the error is. So it becomes much more hard and challenging to do monitoring and observability in general. And yeah, you can imagine if you take this concept into much more complex architecture, like the big scaler of internet are doing, like Uber or LinkedIn or something like this. I don't want to be on call for this kind of architecture. Like whenever there is problem, it's really, really hard to understand what's happening because data is flowing from different direction, and the particular issue become really hard to debug and understand what's going on. So for modern application and mainly cloud native application, you will hear the term of the 3 pillars. Some will talk about the 4th pillars, adding profiling, but it's mainly 3 things. First, metrics is telling you if something is happening. Do you have more error than expected? Do you have high latency in your application? And maybe if is your infrastructure suffering because we are consuming a lot of resource, or at the opposite, we are not using enough resource and you are wasting money in cloud services, for instance. So metrics is usually what you use to show the dashboard. This is where you start the debugging and investigation. And this is also what you use to do alerting. So you can say, if 90% of my queries are slower than 100 millisecond, I want to receive an alert because that's something that impacts the user experience, and I want to be aware of that, and I want to change things. So that's really the first pillar. The second one is logs. I guess the majority of people here know what logs are, but this is like application giving you more context, more details on what's happening, about errors, about connections, about things like this. And again, like traditionally, it was really efficient to find issues, but now with the microservices type of application, it become much harder to understand because you get logs from one particular microservice, but you don't have the end-to-end view. This is where traces become really important, distributed tracing. You get this flame graph where for every transaction, every time a user connect to your website, you can see what are the different APIs and services that transaction went through. And for every one of them, how much time it took to execute the code or bring the data or process it or something like this. So these three pillars should be used together to be able to debug whenever there is something happening. So as I said, you start looking to your dashboard, which mainly based on metrics. You see that there is an issue. You want to move to the logs, but you want to move to the logs to particular service or application or the thing that show that there is an issue there. And you would like to have features in the platform itself that help you do that. And then from the logs, you want to go to the traces to understand what's happening and vice versa. I will show you in a demo how this correlation looks like and how it can be useful for necessary. I don't know if we can stop here maybe and see if there is any questions in the chat. You can post them in the chat and the answer. I will stop for a few seconds. Okay, if there is no question, I can move forward. Feel free to yeah, post your question if you have any, and I can stop and answer them. So when we built this platform for observability, we took into account several items. The first thing is we wanted to build a platform or technology that's has low cost at scale. So when you start using deploying cloud native application, the scale of your application can become really big, especially if your service is successful on internet and you don't want to break the bank just only to monitor this application. So leveraging the cloud native itself by building a microservice based monitoring tool will help us increase and scale, and also leveraging things like object storage like S3 will help reduce the cost compared to storing data on SSD disk or even local disk. The next thing is we want to have something cloud native and really well integrated with Kubernetes. Things like safe service discovery is really important because your application will be dynamic, right? Depending on the load, it can spin up or down some pods. And traditional monitoring tool need to have the exact IP address of the systems that they want to monitor. But here we want solution that's able to detect this dynamic change and start monitoring new services when they appear and remove them from the list when they disappear, so that you don't get alerts all the time because something is missing, but just normal because we are scaling down the platform. And finally, we would like to have seamless integration between metrics, logs, and traces directly. So based on this design pattern or consideration, we built this LGTM stack. So Mimir is for storing metrics, same thing like scalable, low-cost storage, and it can be replacement for Prometheus. I will talk about Prometheus in the next section. Loki is like Prometheus, but for logs. The idea, same thing, is to have a lower cost storage system for logs than Elasticsearch. And finally, Tempo is for the traces. So the idea of this platform is to enable this kind of workflow. Let's say you are like a developer or an SRE, you are on call, you have a critical application that you are monitoring, and there is an issue. So what happened is you get paged by an application or phone call because an alert have been detected, like the number of restart of your, I don't know, transaction service or payment service is too high compared to what we want. Whenever you get this alert, you go into Grafana dashboard, you start seeing metrics, and you understand where the problem is. For instance, this red part, you can see the query per second is above the average that we want. And there is like a full process that kick off so that you can understand what's the root cause of this, and you can solve it, whether by giving more resource to the application or rolling back to previous version of the code that's deployed or something like this. So the dashboard give you a good start, a good overview to understand where the problem is, but usually it's not enough. This is also different between monitoring and observability. Monitoring is you have set of KPI that you look to and that's it. Observability is going into kind of ad hoc slice and dice mode where you can start changing filters and playing with the data like a BI analyst will do to understand where is the problem. So you may start by looking to metrics and you filter down to specific service in a specific region and maybe specific instance or pod. And you see that you are getting closer to the root cause. From that, you would like to see the logs of this particular service. And from the logs, you want to see the distributed trace of how the transaction went from service to service, because you aren't able to understand only looking to the logs. So that's exactly the workflow that the LGTM stack will help you get. So in terms of architecture, as I said, we want to have something scalable, and this is the like really high level architecture of Mimir, Tempo, and Loki. It's based on like microservice architecture. There's different services. Some of them are responsible for ingesting the data into S3. Others are for executing the queries. The nice thing about it is it's exactly the same architecture for metrics, logs, and trace. So if you spend time learning about one of them, you can leverage your skills and your experience and your automation tooling and things like this to deploy the others. The other thing is that since we are using similar query language, similar labeling, and like metadata, it's really easy to move from one pillar to another one. And this is where I will show you in the demo. But before jumping to the demo, is there any question I can answer? Ayub, I think you are on mute. I cannot hear you.
Sorry. I have one question. What is the exact difference between logs and traces? Aren't logs supposed to give us information about which services contact which service?
So the logs will be like really focused. If you write an application, let's say you are a developer,
Yes.
and you are responsible for let's say the authentication service. This is where you look up a user in LDAP or Active Directory, and you verify if the user can connect or not the application. As a developer, you insert logs into this service you are responsible for, and you can say when the logging have been successful or failed, and you can put all the information you think are important to understand what's happening. But this logs doesn't give you like end-to-end view from going to the load balancer, authentication, and then to the I don't know, based on service, for instance, payment service and delivery service and things like this. It doesn't give you the end-to-end view or everything happening. That's where traces are important, and this is where the traces give you another view. For instance, I can show you, maybe it will be more visual here. So this is what I mean by trace, right? So you can see here this. Let me search for a service where there is an error. Up. It will be more interesting. Okay. So this is what we call trace, right? It shows you First, the other difference is that logs give you more details on what happened, but it doesn't give you like the duration of how much time it took. So the trace will give you this kind of visualization when you can see this, that what we call the span. So the end-to-end transaction of your user on the website took all this time. So around 66 milliseconds. Inside it, you can see all the services by which the transaction went. So we did first a post on endpoint, and then we did the query on the middleware, and this took, let's say, 52 milliseconds. And inside it, there is like an express JavaScript framework that handled the transaction. And then there is the JSON parser where we extracted the JSON from the query itself. And then we did Postgres query to answer the data that we got. And inside this Postgres query, you can have all the information. You can get the link to the Postgres query. You can get the query itself, and you can see the errors that happen. So it gives you like this transactional view from end to end in different services. And then if you want to have the logs only for this part, for instance, the Postgres query, you can click on logs and it will give you only the logs for this one. Because if you have the logs of all the services, it's really hard to understand where the problem is, where should I go as a developer to correct things and to change. So does it answer your question?
Yes, thank you so much.
Okay, perfect. Yeah, so going back to the demo, this is dashboard where it's similar to what we call APM, application performance monitoring. There is different methodology that help you build good dashboard. Here we are using red. R is for request, like how many connection you have on your website. The E is error, how many errors you have per endpoint, per service, or something like this. And and duration. This is the latency, how long like every transaction is taking. So why this method is important is because it helps you measure the user experience, like people connecting to your website. If there is a lot of error, it's not good. If the service are taking a lot of time, it's not good. So it's much better than having like a KPI on CPU, RAM, and things like this, because it doesn't make sense. Sometimes you get an alert because CPU is too high, but your user are not impacted by that. So when you look to this dashboard, for instance, there is different things you can see. So here, this is the graph. I will stop auto refresh. This graph one, you can see the latency of my service, and it's clear that around 7 p.m. 25 there is problem because the latency is going up. So there is different way you can start investigating. You can go from metrics directly into the traces. You can see these points here, for instance. These are what we call exemplar. It's taking particular transaction that has a problem and it shows it on the graph, so that you can go and click directly on the traces, and you can have the transaction and see which part of the code, which part of the microservices itself took a lot of time, so that you can focus on that and solve it. So that's one of the workflow. The other workflow, the one I like more is this one. So the dashboard tell you that there is a problem, and then you can go into the explore mode to start like investigating. So here, it's clear that we have like different endpoints, and there is problem here around this time, but it's not really clear what's happening. So what you can do is split your screen and go into the logs, so Loki. And what you notice here is the data is filtered automatically for you, because here we had this label that help us get metrics for the production service, the mythical server service from the production environment. And this have been automatically filtered. So all the logs I see here is only the logs for this particular service. And you can also sync the time. So for instance, if I select here, let me disable the exemplar because they are annoying. So if I filter here to see what's happening, I only get the logs to this particular time. So the two are synced together. And it's become much efficient to find the errors. So for instance, here I see these logs in red. So what's telling me here is that I have error null value in column, but imagine that your application have 10 microservice. Every microservice is using database. So which database are we talking about? Is it the database for authentication? Is it the database for data analytics, or is it for something else? Which microservice are we talking about? So the log doesn't give you the full picture. It just tells you some more details around what's happening. So when you click, but inside the logs, if you have put the trace ID, you can go there, and from the trace ID you get this view I showed you in the beginning. And here I can clearly see that the problem is this Postgres insert, and I have all the information that help me see where the problem is. And then I click on logs, and again I get logs really specific for this particular microservice around the time where the problem was happening. So as an SRE, it's much efficient for me to go and see what's happening there. So I will stop here and see if there is any questions. So all this, what I'm showing here is like open source tools that you can download and deploy inside your environment and use them. There is also a SaaS, like a cloud version. When you go to Grafana Cloud, there is free tier that you can create. You don't need to pay for it. It comes with it's forever free, so there is no, let's say, 1 or 2 weeks only, and you have enough data if you want to learn or play with. So you can send up to 10,000 metrics, 50 gigabytes per month, and of logs and of traces. So that's pretty interesting if you want to start learning and using the platform without deploying everything yourself. And then when you create the cloud, it looks like this. So you can get there, you can add stack, you give it a name. You can define in which cluster it's deployed, and you create stack. And then what happened behind the scene is you get everything deployed for you: Grafana, Loki, Mimir, and Tempo. And you have the information that you can use to start pushing the data. So you have the endpoint, and you have the user ID, and also the configuration that you need to add into your agent or Prometheus or something like this. And of course, the Grafana UI is here. You can click, and it takes some time to load it the first time, but I have other things deployed here. So you can launch your Grafana. And then let's say you want to monitor, I don't know, maybe MySQL database. You can here search for MySQL. You select the OS that's running on. And what this integration does is it gives you the configuration you need to run to download the agent, configure it, and it will start sending the data to cloud. And then you will have dashboard that have been created for you, for instance, integration MySQL. And you can see there is a dashboard that we think are good to monitor MySQL, and you will have different KPIs. So here I have no data because I didn't really execute it, but if you do it, you will get all the information. So for instance, here, if I go to, I don't know, my Confluent Cloud, I'm monitoring Kafka cluster. So you can see you get these metrics that are available for you based on what the agent is monitoring and things like this. So that's the easiest way to start and use this stuff. Okay, perfect. I will move forward and maybe talk a little bit about the metrics part, because that's the first thing that people start with, and then we can conclude there. So in the past, being Grafana, we have more than 10 million of users of Grafana. We have more than 1 million instances in open source deployed all over the world. And starting in 2016, 17, 18, we started seeing that Prometheus become the standard for monitoring Kubernetes and cloud native. So today, if you deploy any Kubernetes, whether it's vanilla or managed by cloud provider like GKE or AKS or something like this, by default, Prometheus is the standard tool to monitor the Kubernetes cluster, but also all the workloads that are running inside it. So the way Prometheus works is pretty easy. You have its like lightweight server that try to connect to web page in which you have the metrics that are described in pretty simple format, which is metrics name and the value. And your Prometheus service is configured to scrub. Scrub meaning collect this database, this web page, collect the information in there, parse them, and then store them in database on a different frequency. For instance, every 15 seconds, every minute, or something like this. And the configuration is pretty simple. You say, okay, this is my Prometheus. I need to monitor this target, which is on 127.0.0.1, port 12345, and I want to monitor it every 15 seconds. And then the result of that is stored in Prometheus, and then you use Grafana to monitor. So it's pretty simple. This is how it works. So how do you get this page and the metrics in the format that Prometheus expect is you use what we call exporters. So there is different scenarios. If you are the developer of application, you need to take care of exposing these metrics. So usually here we are talking about business metrics, for instance, number of users, numbers of products sold, and things like this. But if you want to monitor Linux server, MySQL server, or like famous technologies, the community have done really great job on building all these exporters. So that's like a utility that you install, and it collect metrics and data from the system, let's say the Linux system, and then expose them with this format. In some cases, you are not allowed to deploy the exporter. So there is also an SNMP exporter, for instance, that can collect and receive this information via the SNMP protocol and then expose them. So the Grafana agent or Prometheus will collect all of these and show it. In terms of query language, it's again pretty easy. The data model is composed of 4 things: a timestamp, a metric name, like say CPU usage. You have one or many labels that this is what you use to filter and choose the data you need. So it's like a set of key value pairs. Let's say data center, application name, service, and things like this. This is what you use to filter. And then the value, which is the value of the metric. So if it's CPU usage, it's the value of the CPU usage. And when you are in Kubernetes, there is a service discovery which is pretty powerful. It's Prometheus talks with the Kubernetes API to discover what are the services that are deployed, and if there is like any new services that become available, your Prometheus will be aware of that and can scrub them and start monitoring them automatically for you. And finally, the query language is PromQL. So it's really rich. It's kind of specific. It's different from SQL or something that you may know, but it's really powerful because you have different data type. different operation of grouping, joins, rate calculation, and things like this. But it's really focused on the observability. So that's something that you will need to learn if you want to use Prometheus, for instance. Because of these things, it's easy and lightweight to deploy. The data model is pretty straightforward. It works well with service discovery, so it's really good for monitoring Kubernetes. The large number of exporter, and finally PromQL, Prometheus become, like as I said, standard because a lot of people love it and it's the default solution that they use. However, Prometheus have been built with this limitation in mind. So it's not a distributed system. It's only one instance. So it doesn't have high availability. If you want to scale it, there is only vertical scalability, and it comes with some constraint. There is no security. Like if anyone have access to Prometheus, they can see all the metrics from all the systems that you are monitoring. You cannot say, you can see only data center 1, but not data center 2, for instance. And finally, it has been designed to store data for a few days only or few weeks, not 1 or 2 years of data. In some use case, you need to keep them longer to do, for instance, machine learning or forecasting or anomaly detection and things like this. So to solve this challenge, there have been many solutions in the open source. You can hear about Cortex or Thanos or Victoria Matrix or something like this. And at Grafana, we built this architecture that we call Mimir, which is a distributed architecture where the read and the write path are completely different. So you can scale the write or scale the read independently. If you have a lot of data coming, but not much queries, you can do that. In the opposite, if you have a lot of queries but not much data, you can increase the read path and things like this. And all the data is persisted in object store. Of course, there is cache at different layers that make things go fast, but that's really where the bulk of data is stored. So it helps you get like really scalable data for storing millions or billions of metrics, but the cost is low. And there is also this service that we call compactor that takes the data and like aggregate it into an efficient way so that you always have queries that are fast. So what's the link between Mimir and Prometheus? Mimir can be replacement of Prometheus if you need this scalability and this high availability or security things. So like it's centralized cluster that you can collect data from all your application all over the world. If you have Prometheus already in like monitoring, it has something called the remote write that can forward the data into central location. If you don't have it, there is like lightweight version of it, which is agent that do same thing like scrapping and push the data without storing it. So that's how it works. And in terms of scalability, we have tested this architecture to go up to 1 billion series. So it's pretty powerful. There is a blog here where we explain all the details of the benchmark and how we did it. So I will stop here and see if there is any questions. Okay, if there is no question, we can move forward.
I had one question.
Yeah, go ahead, Ayub.
What about the pricing of Mimir?
So everything is open source. You can deploy it yourself, so it's free. You can. There is different way to deploy it. It can be single binary, like just one instance, and you run it in a VM or in a pod inside Kubernetes. If you want to have a distributed version, you can use Helm charts to deploy it in Kubernetes, and again, it's free. And now, if you don't want to manage it yourself and you want to use the cloud version, for instance, as I said, there is like Grafana cloud pricing. So everything is public. You have this free tier where you can go up to 10,000 metrics. If you have more than that, you can go to the pro plan, and we looked at the number of metrics, and it's like $1 per month for 1,000 active series. So depending on the number of systems that you monitor, the cost can be different. But as I said, it's open source, it's free, it's on GitHub. You can download it and start using it. Any other question?
I think the community is shy today.
I hope I didn't lose them. It's pretty, maybe it's an advanced topic.
No, I think the talk was very clear.
Okay.
Shall we continue?
Perfect. Yeah. So let's move to the last part of the presentation. It's logging. So Elasticsearch, Splunk are really famous logging systems. Like a lot of companies are using them. But when we talk with their users, we hear often three complaints. The first one is it's hard to scale. If you have used Elasticsearch before, you know that you need to manage different replicas. It's really hard to scale the index part. Sometimes the index itself is bigger than the data. And whenever you go over a certain scale, it becomes really a nightmare to manage. It's also really expensive in terms of hardware that you need to throw at it to work at a good level, but also all the time that it requires the team and the engineering to run. And finally, for people that are using cloud native application and Kubernetes, so they are using Prometheus, it's hard to move from metrics to logs, and they don't have this correlation. That's why we started the new project in 2018 called Loki. It's like Prometheus for logs. So we kept the same principle, similar query language. The service discovery works as well. The labeling system is the same. And then we started adding new features and version after version. And the community is really great. Like a lot of people moved from Elastic to Loki. For instance, OpenShift replaced the default logging solution from Elasticsearch to Loki. Same thing, Prometheus community recommend to use Loki now instead of Elasticsearch and things like this. So the idea of Loki is that we don't index all the logs, we only index few labels. So it makes the index really small, and it make it easy to scale, and the cost is reduced. So if you have logs, you have the content, you have a set of labels exactly like Prometheus, like which application is this, which cluster is this, and we index only this part, but not the rest of the logs. It means like if you have 10 terabyte of data per day that you are storing, the index is not 10 or 20 terabyte, it's only 200 megabytes. But you can ask yourself, but if you don't index, the query will be slow. Yes, it can be slow, but we are not trying to replace Elastic everywhere. We are focused on logging use cases and observability. And in these use cases, you are not willing to search all your database. You are looking for a particular problem. So what you will do is set a time frame. For instance, I want to search a log for the last hour or last day, or between 1 p.m. and 2 p.m. last week, because you are looking for something particular. And when you look, you don't want to look to all the logs that your company has. You want to look to the log for particular application or service because you looked at the metrics and the dashboard, and you know you have an idea where the problem is. So you will position the logs. It means that the data you need to parse go from 1 petabyte to, let's say, 80 terabyte. And then you set up time frame, it will go down to 1 terabyte. and then the rest of it you can search for it. And since it's microservice architecture, you can go fast and search over the data. So here you have smaller indexed, so you pay less money, but for this SRE and observability use case, the speed is enough to be used. So it's really like a better trade-off between systems like Elasticsearch or Splunk that are based on things like Lucene or like any indexing system versus Loki, where it has like a better way of handling these use cases. So just to give you some numbers, we have some big Loki clusters to give you an idea on the scale. We are ingesting 700 megabyte per second. So it's around 43, 45 terabyte a day. So it's a lot of data. It's more than 1 petabyte per month. And we have 4,500 different tenants. Tenants is a customer in our case. On the query, we can parse like up to 80 gigabyte per second for one particular query. So we have like a lot of, it's a busy cluster. A lot of people are querying and searching for logs and things like this. But the logs themselves are not only to be searched. You need also other features. So you can do filtering and indexing. For instance, here in the query, you can see filtering for this particular job, it's Nginx, and I want to search all the logs that have the Mozilla inside it. The logs are JSON format, so I want to parse them. And then I want to filter only the logs that are coming from the US and request time is superior than 100 milliseconds. So the query language is pretty powerful and you can do wherever you want. The other things around it is you can extract metrics from the logs. It can be metrics on the log themselves, like how many logs per second we are receiving for this particular filter. And it can be also looking inside the logs, extracting information, and then storing it as a metric. I can show you a quick demo here to finish with that. So let's say I have an e-commerce website. I don't use metrics because it's legacy application. I only have logs. I have built this dashboard, which is full of metrics, but everything here is based on logs. This is the logs coming from Nginx. So you can see here the number of users per region in every country. So in Algeria, we have only one visitor. In France, we had 2, and things like this. You can also see different metrics. I can show you here. So the data source is Loki. We are counting over time the number of logs and summing this count by status here. So this is where you see the status. So again, it's metrics, but that we are extracting from the logs. And you can even go and do stuff like 95 percentile, where here we are taking quantile over time of the logs. We parse the logs that are in JSON format. Inside the logs, we have a field that's request time, and that's what we count, because the logs looks like I can show you here. Explore. The logs looks like this. So this is all the fields that we are collecting from the Nginx server, and request time is here. So that's the field that we are extracting and converting into metrics. So different use case, you can do alerting, you can do a lot of stuff with that. What you need to keep in mind is you can have solution that's easier to use, easier to manage, lower cost, it's open source, and it works better than Elasticsearch for the observability and monitoring use cases. So with that, I will stop here and see if there is any final question. I hope it was not too detailed or complex for you to grasp.
Thank you, Abdelkrim, for the session. It was very fruitful session. I have a question, if I may. We talked about the LGTM stack. Generally, when we have our application deployed, when we use the LGTM stack, all the LGTM stack. But for example, if we want to use for example, CloudWatch, the AWS CloudWatch, how should we deploy all the stack to use it, or how?
That's a great question. No, you don't need to deploy everything. Let me show you this. So at Grafana, we have this philosophy that we call Big Tent, in which we don't force like users to use all the platform in a whole to take value. Because Grafana have all these different plugins, you can pick only one. For instance, you use Prometheus or Mimir for metrics, but if you have CloudWatch logs and you are happy with it, you can keep them. And then you can put everything in the same dashboard because you have these plugins. So for instance, in this particular dashboard, I have metrics coming from Prometheus, and I have some data coming from Snowflake. The logs are from Splunk. I have some ticketing information from ServiceNow and things like this. So in Grafana, there is plugin for all the monitoring tools for cloud providers, Google, Azure, and AWS. You can use them, you can extract the information, and if you need to have other things like Mimir, Loki, or Tempo, you can use them as well.
Thank you so much.
Sure.
So if there is any question, please just ask the question. Ayub, do you have any question?
For the moment, I don't have any question. I think everything was clear for me.
Okay, perfect. So I guess we.
So I think yes, we did the show 1 hour, so it's enough. So thank you, Abdelkrim, so much for the session, and we were very glad to having you. Especially, you are the first Algerian that we are having in the CNCF community. So thank you so much, and I hope we can collaborate again in the future, inshallah.
Inshallah. I think you are on mute, okay.
Yeah, thank you very much for having me. Thank you for the invitation. Really glad that that we did this session together. Feel free to reach out if you have any question in the future. Happy to do more dedicated or detailed session if there is one particular area or tool that's of interest. And yeah, wish you all good luck in organizing these events, which are great for our communities in Algeria.
Thank you so much. So the last word, Ayub, so we can finish.
I'll just thank Abdelkrim for this insightful talk. I think it was very easy to follow, and it was good to learn about the new observability and monitoring tools. Thank you.
Perfect. Glad you like it.
So we will finish the session. Thank you for attending, and hope to see you in another session. Goodbye.
Inshallah.
Thanks everyone. Bye bye.